completed up to the preparation of hydrogen in laboratory method. Okay? So, and in evening class, the class was not completed due to the poor network. So today we will start from the impurities of hydrogen. Okay. Impurities of hydrogen. Remember, when hydrogen is prepared in laboratory method, so the prepared hydrogen contains so many impurities compounds with it. Okay, like it contains hydrogen sulfide, that is H2S, some of the oxide of sulfur, that is SO2, some of the oxides of nitrogen, okay, oxides of nitrogen, phosphine, arsine, carbon dioxide, water vapors, etc. Okay, so we need to separate this all compound, and to separate this compound, we need to pass that hydrogen with different solution or different chemical compound. Different substances will separate different impurities from hydrogen. Okay, like for H2S, we will pass silver nitrate solution. Sorry, for H2S, we will pass lead nitrate solution. Okay, because lead sulfate will be precipitated out. Okay, for SO2, for CO2, for NO2, oxides of sulfur, carbon, nitrogen, to pass separate the oxides of sulfur, carbon dioxide, and nitrogen, we will pass the any alkali, strong alkali. Either it will be NaOH or it will be KOH solution. Okay, so come here to look at the reaction. First reaction, to separate H2S. Okay, H2S separation. To separate H2S, we will pass lead nitrate solution through the hydrogen mixture. Means some chambers are formed. One chamber contains lead nitrate solution. Then hydrogen gas is passed through lead nitrate. All H2S will be absorbed in lead nitrate solution, and then hydrogen will be removed out. Then removed hydrogen will again pass with the silver nitrate solution. So to pass silver nitrate solution, phosphine and arsine will be separated out. Then it will be passed with the alkali solution to remove SO2, KOH, etc. Okay. So when when hydrogen is passed through lead nitrate solution, then H2S reacts with lead nitrate to give lead sulfide, one kind of double displacement reaction that will be discussed in next chapter. Lead sulfide and 2 molecules of nitric acid. Clear? So now H2S impurities being separated out with the lead nitrate as lead sulfide precipitated out. Next, to separate phosphine and arsine. Okay, phosphine and arsine. To separate phosphine and arsine, we need to pass the hydrogen through silver nitrate solution. So when through silver nitrate solution hydrogen gas is passed, then The phosphine or arsine present in it reacts with silver nitrate to form the precipitate of silver phosphide and here silver arsine. Okay, and simultaneously it forms some nitric acid and some amount of silver nitrate remains unreacted. Okay, some of the silver nitrate remains unreacted. After that, which impurities are left over? H2S is being separated out by lead nitrate solution. Phosphine arsine is being separated out by silver nitrate solution. Next, the oxides. To separate oxides, okay, all the oxides, sulfur oxide, nitrogen oxide, carbon dioxide. So what I have told that to separate oxides, we need to pass a strong alkali, suppose KOH or NaOH. So when the rest of the mixture is passed through the KOH, then the impurities like SO2, CO2, NO2, it's react and it form potassium sulfate, T2CO3, T2SO3, here T2CO3, and here mixture of TNO2 and TNO3, potassium nitrite and potassium nitrate, okay, with H2O. And lastly, only water vapor remains. So to separate water vapor, we supply that hydrogen mixture through drying agent to separate water vapor. Okay, to separate water vapor. To separate water vapor, drying agent like caustic potash, KOH, phosphorus pentoxide, P2O5 are supplied. Okay, remember here, concentrated H2SO4 are also drying agent. It can absorb water molecule, but here concentrated H2SO4 is much more reactive, so it will react with hydrogen, the produced hydrogen, and to convert it into water and SO2. That's why concentrated H2SO4 cannot be used. Okay, so how this separation of impurities done? No, but up to this completed. Have you written it? Have you wrote it?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Look at here. If we will pass concentrated H2SO4, then concentrated H2SO4 is a strong oxidizing agent, we know, okay? And it will react with hydrogen to gives us H2O and itself converted to SO2. So we will not get in hydrogen after the passing of H2SO4. We are getting H2O, but the desired compound is hydrogen. That's why concentrated H2SO4 is not used. So concentrated H2SO4 is not used as drying agent here. Okay, other cases may use it can be used, but here not. Next, listen. What are the precautions we should take for the precautions we should take for take when we prepare hydrogen? No, apparatus should be airtight. There should be no leakage of gas. No flame burning near the producing gas. Okay, that should be collected only after the all impurities separated out. Okay, these are the some precautions. You can read it. Next question: why nitric acid is not used for preparation of hydrogen? So remember, nitric acid, the question is coming for nitric acid and concentrated H2SO4. Okay, both are not is being used. Only dilute HCl or dilute H2SO4 is being used. Remember when I wrote the preparation, then I told that the dilute HCl or dilute H2SO4 is used with zinc. So why not HNO3 and H2SO4? So remember, nitric acid is a strong oxidizing agent. A strong oxidizing agent even in dilute state. Even in dilute state means left the concentration, left the concentrated nitric acid is very strong oxidizing agent even in dilute state. Okay, so if we use nitric acid, then we will not get in the hydrogen because nitric acid will oxidize the produced hydrogen into water. Similarly, concentrated H2SO4 is a strong oxidizing agent, so it will oxidize hydrogen into H2O. Clear? But dilute sulfuric acid, dilute HCl are using because they are not so much strong oxidizing agent. Okay, so nitric acid is strong oxidizing agent and concentrated H2SO4 also. So you can write both the answer same. So what are the reactions when nitric acid is being used? Now, if zinc and nitric acid taken, okay, then it gives zinc nitrate. Hydrogen is being oxidized to water and itself form NO. Okay, sometime it will be NO2 if the concentration is too much high. Zinc plus concentrated H2SO4, then it forms zinc sulfate. Okay, but hydrogen is being oxidized to H2O and sulfur dioxide. Okay, only two metals are able to produce hydrogen with reaction with nitric acid. But the nitric acid concentration is very dilute. Okay, remember, only magnesium and manganese are able to produce hydrogen gas with very dilute nitric acid, that is 1%. Okay, the reaction is, suppose magnesium plus nitric acid, 1% nitric acid, then it forms magnesium nitrate and hydrogen gas. Okay, in laboratory process, generally we prefer zinc. Others active metal we are not using because potassium, sodium, metals are very much reactive, they take place this reaction with explosion. So we avoid sodium, potassium, they very explosively and expensive. Calcium, magnesium are expensive. Okay. Aluminium forms protective layer Al2O3, so it will not produce hydrogen. And lower reactive metals are not able to give hydrogen. Okay, that's why on the base factor of everything, we should remember that zinc is suitable for the preparation of hydrogen. Next, some other processes to prepare hydrogen. Having any doubt till now?
No, sir.
Okay, so can you write the answer of these two questions? समझा दिए that what are the precautions? What are the precautions to the preparation of hydrogen? And other metals are not used in laboratory to prepare hydrogen. दोनों समझ में आया? Answer, can you write these questions? Answer of this question, can you write? Okay. So now, manufacture of hydrogen, other processes. Okay. So by the electrolysis of water, other processes for preparation of H2. So in other process, we will discuss first, that is by electrolysis of water. By electrolysis of water. Look at here. As we know that pure water is not conductor of electricity. Okay, we know that pure water is not conductor of electricity. So we add some dilute acid, H2SO4 or HCl. Okay. Now, on the passing of electricity through this acidic water, water will be decomposed like this: H plus and OH minus. Okay. H plus is iron, this is cation. OH minus is iron, this is anion. Now this water is present in this kind of cell. This kind of one beaker is taken. In this beaker, two metallic foil is placed. Okay, two metallic foils are attached with the, this is wire and this is battery. Okay, and here that acidic water is present. Here that acidic water is present. These two are metallic foils. Okay, these two metallic foils are called electrode. Okay, metallic foils are called electrodes. Here, this is where electric wire. Okay, and this is battery. Now this is the smaller end, this is the positive end. Which one is negative, which one is positive?
Sir, the small one is negative.
Small one is negative, longer one is positive. Now remember, the electrode which is attached with the negative end of battery is called cathode, and it is negative charge as it is attached with negative end of battery. Okay, and this electrode which is attached with the positive end of battery is called anode, and as it is positive end of battery, so it is positively charged. Now during through this setup, electricity is being passed through battery and wire and metallic foil, and metallic foils are connected with acid water, so the complete circuit is present. And during this electricity passing, that water molecules decompose like H plus and OH minus. So now tell me, this H plus and OH minus, if float over this solution here, H plus is being positively charged and cathode is being negatively charged. So H plus will be attached to the cathode, or H plus will be attached to the anode.
Sir, anode.
Why?
Sir, because cathode is negatively charged and H plus is positively charged, so it will attract.
So H plus same charge will attract each other, or opposite charge will attract each other?
Sir, opposite.
Opposite charge. That means yeah. Opposite charge. Look at here, H plus cation, OH minus anion. Cation goes to cathode, OH minus goes to anode. Remember this, okay? So when H plus comes to cathode, then what happened at cathode? Clear? No, everybody, this is clear to you that why H plus goes to cathode?
Yes, sir.
Yes, sir.
Okay. So at cathode, H plus comes. Now H plus means it has electron density less. This is minus, means electron density more. Now remember, every ion having the tendency to lose its charge, or every ion having the tendency to neutralize itself. So tell me, to neutralize itself, to neutralize plus 1, neutral means 0. So to neutralize itself, H plus having requirement of electrons, or it will lose electron. To neutralize H plus, अगर इसको 0 पे जाना है तो H plus क्या करेगा, इलेक्ट्रॉन एक्सेप्ट करेगा या और इलेक्ट्रॉन लॉस करेगा?
Sir, accept.
Accept करेगा. How many electron it will accept? It will accept 1 electron, as here only plus 1. So at cathode it forms H. After that, 2 hydrogen joins with each other to forms hydrogen gas at the cathode. Similarly, what happened at anode? OH minus comes here and OH minus. Anode is positive. So anode having the lesser density of electron. So OH minus will donate its electrons to the anode. So here OH and electron donated. After that, 4 OH joins with each other to form 2H2O and oxygen gas. Okay. This is the electrolysis of water. That when electric current is passed through the uh, acidic water, then water decomposed as H plus and OH minus. H plus being cation, it goes to cathode as it is positively charged, will be attracted by the negative end of battery, negative end of electrode, and OH minus itself it is negative charge, so it will be attracted to the positively charged anode. So H plus is itself plus, so it will accept electron and convert in this reaction. OH minus itself negative, so it will convert into OH and electron. Next, Bosch process. Okay, in other process we are discussing about certain Bosch process. Look at here, Bosch process is the collection of some steps. Okay, at first, in first step, red hot probe. Okay, red hot probe, that is carbon. Okay, red hot probe is passed with steam, is passed with steam at high temperature, almost 1000 degrees Celsius. Okay, red hot carbon is passed with steam. Then what happened? Steam means H2O. Okay, so look at here, carbon will attach oxygen, attached with oxygen, and removing this hydrogen. So it will form CO plus hydrogen. Okay, this mixture CO and H2 mixture is called water gas. Remember, this is MCQ question. What is water gas? So at first, red hot carbon is reacting with steam to this carbon monoxide and hydrogen gas mixture. This mixture is called water gas. But here remember, look at here that hydrogen is present with CO. Water gas a mixture. So we have to separate out this CO. To separate out that CO, we will pass that mixture, CO plus H2 mixture, with excess of steam. Okay, excess of steam. So when we pass excess of steam in presence of some catalyst like Fe2O3, okay, this is catalyst Fe2O3 Cr2O3 we can use near about 450 degrees Celsius temperature. Then this CO will again attack this oxygen, and this CO converts to CO2 and leaving the hydrogen gas. So hydrogen plus hydrogen, 2 hydrogen. Okay, and here heat. This reaction requires the temperature. So this is endothermic, and here heat energy is released. So this is exothermic. Okay, I have written it here. Okay, here minus heat. So minus heat means this will be converted to here plus heat. So this is endo, and here plus means it is
exo. First step is endothermic, second step is exothermic. Now the CO2 have been produced with hydrogen, so we have to separate out this CO2. So remember, in laboratory method, when CO2 was produced, what was the compound through which hydrogen gas should pass to remove the CO2? Remember, when CO2 or SO2 NO2 was produced, we pass that mixture through KOH. So here again we will pass this mixture through KOH. So when KOH is passed, then with reacting with CO2 and hydrogen, it gives K2CO3 as a salt and hydrogen unreacted. Okay, and lastly some amount of water also formed here. Okay, K2CO3 and इसे यहाँ मत लिखो, छोड़ दो, इसे यहाँ वाटर करो, बिकॉज इम्प्योरिटी सेपरेट कर रहे तो CO2 जो है CO2 reacts with KOH to give K2CO3 and H2O. And lastly, if there is any carbon monoxide present, okay, if there any carbon monoxide present, then that carbon monoxide reacts with cuprous fluoride, okay, cuprous fluoride, ammonia tell cuprous fluoride, okay, this is ammonia tell cuprous fluoride solution. Ammonia tell cuprous fluoride solution means water. Then it forms adder compound CuCl dot CO dot 2H2O. Okay, CuCl will absorb the CO if any kind of carbon monoxide is present there. Okay, so it will absorb and all the impurities left separated out. So now hydrogen is present. Hydrogen is prepared purely. Okay. Done.
Yes, sir.
Okay. From natural gas, we know that if methane is burned, then CO and H2 is formed. Okay, CO and CO2 and hydrogen is impure, uh, incomplete combustion. Then CO and H2 is complete combustion. Then CO2 and H2. Okay. So how can we test hydrogen gas? Can you tell me? How can you test hydrogen gas? Suppose hydrogen gas is producing or not. How can you distinguish that is hydrogen produced or not? We will take hydrogen near a flame. If it will produce a pop sound, then it is hydrogen. Okay, this is the test for hydrogen. Clear? Clear?
Yes, sir.
Okay. Next, we will go to discuss some physical properties of hydrogen and some chemical properties of hydrogen. So here, physical properties of hydrogen. So remember, hydrogen is colorless. Okay, color is colorless. Odor is odorless. Okay, tasteless, non-toxic. Okay, less soluble in water, less soluble in water. Okay. Lightest element. Those are the physical properties. Lightest element, lightest gas when it is in element form, lightest element when it is gaseous form, then it is lightest gas. Okay. Next, we will understand some terms like occlusion. Okay, occlusion or adsorption. Occlusion or adsorption. What is the meaning of occlusion or adsorption? No. Suppose this is any metal surface. Okay, this is any metal surface. So hydrogen having the great affinity or great attraction to the metal surfaces, like and especially to the nickel, platinum, or palladium. Okay, to the surfaces of nickel, platinum, palladium, hydrogen having the great affinity. So hydrogen will placed over here like this H bond H. It will be placed over the surfaces over this metal, and this is called adsorption. Okay, hydrogen is being highly adsorbed by this platinum, palladium, nickel at room temperature. Okay, this phenomena is called occlusion or adsorption. Adsorption means only at the upper surfaces the gaseous particles are present, and absorption, this D will be substituted by B. If it will be absorption, then these molecules enter into the compound. Like here, this surface, here pen is present. So we can say this is adsorption. On the upper surfaces, this is adsorption. But if it will enter into the compound, then it is called absorption. Okay. So we can say that hydrogen is readily adsorbed by nickel, platinum, palladium at room temperature. This phenomena is called occlusion or adsorption. Now suppose if you have a question that how will you prove that hydrogen is a very light gas? How we will prove that hydrogen is very light gas? Then what should we do? We will take a soap solution. Okay, we will take soap solution and allow hydrogen gas to pass through it. Then air bubbles then air bubbles of soap containing hydrogen will fly and burst. Okay, soap bubbles, hydrogens are lightest, hydrogens are lightest, so it will be fill in the air bubbles of soap, and it will fly over because hydrogen is lighter, and after some time it will be burst out. Okay, these are the physical properties. Next, chemical properties. Look at here. Hydrogen having the great affinity to the reaction with non-metals. Okay, so chemical properties mean reactions. The reactions with non-metals. Like if hydrogen reacts with oxygen, it forms. If hydrogen reacts with Cl2, it gives. फटाफट बताओ. Here, if hydrogen reacts with water, oxygen, then it gives
Sir, H2.
water. H2 reacting with O2, it gives H2O, na?
Yes, sir.
H2 reacting with Cl2, it gives
HCl.
HCl. Ammonia, it gives hydrogen sulfide. Okay. Remember, this hydrogen oxygen mixture is very much hydrogen oxygen mixture. Hydrogen oxygen mixture forms an explosive. Okay, forms मतलब hydrogen oxygen mixture is explosive in nature. Okay, but if the concentration of oxygen is less, then this explosion is being reduced. Okay, this mixture is called, this is called detonating mixture. Detonating mixture. Okay, so if you will be asked that what is detonating mixture, then hydrogen oxygen mixture is called detonating mixture, because when hydrogen burns with oxygen, air means oxygen means air, so it burns with pop sound. Okay, now this process is called Haber process, by which ammonia is being prepared. In class 10, in class 10, the chapter is present ammonia, that we will read again on that position, that hydrogen reacts with nitrogen to give ammonia by Haber process. In this process, catalysts are used. Some catalysts are used. Catalysts are finely divided iron. Okay, finely divided iron, and some promoter are also used. Promoter is molybdenum, MO. Okay, under high temperature and high pressure. Under high pressure, like 200 to 900 atmospheric pressure, and near about 450 degrees Celsius. This is Haber process. This H2 and Cl2 mixture gives HCl. Okay, this reaction carried out slowly in the sunlight. Okay, because direct sunlight, in direct sunlight, this is explosive reaction. Direct sunlight makes explosion. Remember. Okay, this is the reaction with non-metals. Next, reaction with metals. So remember, with metals, it produces hydrides. Okay, hydrides. Like if hydrogen reacts with sodium metal, it gives NaH, sodium hydride. Okay, in presence of some amount of heat. If hydrogen reacts with potassium, it produces KH. If hydrogen reacts with calcium, it produces CH2. Okay, hydrides. And these hydrides react with water to give hydrogen again. Okay, like if calcium hydride reacts with water, it will produce calcium hydroxide and hydrogen again. So with non-metal, it produces other compounds like water, HCl, NH3, H2S, etc. But with metal, it produces hydride, and those hydride reacting with water to give hydroxide and hydrogen gas again. Okay. Next, as a reducing agent, we know that hydrogen is a strong reducing agent. It will reduce some metal compounds. Okay, like suppose if we supply Fe2O3 through hydrogen, then here it will form hydrogen and H2O. Suppose if we pass copper oxide hydrogen, then it will form Cu and water. Lead oxide, then hydrogen, then it will form lead plus H2O. So all of these are reducing in all the reactions. Hydrogen behaves like reducing agent. Hydrogen reduces lead oxide into lead. This reaction are reduction reaction. Okay, and hydrogen itself being oxidized. Okay, hydrogen itself being oxidized. ठीक है, नोट डाउन हुआ? Last, hydrogenation. हाइड्रोजनेशन का मतलब होता है, हाइड्रोजनेशन मीन्स adding of hydrogen in unsaturated organic compound in presence of platinum or palladium to make saturated compounds. Means unsaturated means to converting unsaturated compound into saturated compound by the passing of hydrogen in the presence of nickel, platinum, palladium is called hydrogenation. How these reactions happen? Look at here. Unsaturated means there is a multiple bond between carbon and carbon. It can be double bond, it can be triple bond. As we know, carbon valency is 4. It will be discussed elaborately in class 10. Now it is briefly. This is unsaturated compound where carbon-carbon double bond present. We pass hydrogen in presence of nickel, platinum or palladium, then hydrogen, here two hydrogen will attach with two carbon, and double bond will break to leave in one single bond. Two hydrogen were present initially. Now these two hydrogen are attaching with one with this and another with this. So this is unsaturated because it contains multiple bond, double bond, it can be triple bond. But this is saturated because there is no such kind of multiple bond. All are single bond. Okay. This is ethene. This is ethene or ethylene, and this is ethane. Okay. So this is the hydrogenation, that is adding of hydrogen to the unsaturated organic compound to convert it the saturated compound. Okay. Can you tell me what are the uses of hydrogen? Have you any idea?
Sir, in propelling rockets.
Speak up loudly.
Sir, in propelling rockets.
Okay, in propelling rockets. Anything else?
Sir, for weather forecasting balloons.
Okay. Okay, uses of hydrogen will be discussed in next class, and it will be completed in a 10 to 15 minutes. Then we will start the new chapter, that is chemical reaction. No.
Yes, sir.
Okay. The only uses of hydrogen is left over. It will be discussed in next class, and new chapter will be started. Till now, have been any doubt? Physical properties, chemical properties, preparation, impurities, separation, anything?
No, sir.
No, sir.
Okay. Okay. So, wait a minute. So, your first chapter was completed. That was, I think, language of chemistry, no?
Yes, sir.
Sir.
Language of chemistry. Then I have completed water, then periodic table, and now hydrogen.
Yes,
And
sir.
Anil sir has completed atomic structure and study of gas laws.
Yes, sir.
Okay. Okay. Thank you. So in next class, uses of hydrogen completed, and chemical reactions will be started. Okay. So see you in the next class. नोट डाउन कर लिए थे?